after about 5 minutes, the time comes first. So I just use 5 for example. Then for F, the reaction of E comes to a stop at the end of about 20 minutes. So the volume of the gas produced from both will be the same. That is at the end of the reaction. But at any point before the end, the volume will be different. Do you get that? So A is correct. Now let's check the other option. Option B says F is What is it?
I wanted to ask a question on that surface area before we proceed, sir.
Okay.
Can you hear me, sir?
I can hear you.
Yeah. In one of the textbooks I was going through, I was saying something like lump, granule, and powder. I don't know how it's been related to surface area. If you can explain, sir.
I explained lump the other time now. I told you lump is just like your Maggi cube. That is lump form. Maggi cube or sugar. Then when you grind
Yes,
this, you have the powder form. That's the powder.
Okay, sir.
Very good.
Okay.
I talked about that.
Yes, sir.
So this is
so like how about
what?
How about granule?
Granules are like a powder form too, or a little bit bigger than the powder form. Do you get it?
Okay, sir. Thank you, sir.
Do you get it?
Yes, sir. Yes, sir.
Okay.
We are with you, sir.
B says F is weaker. F is a weaker. And something is wrong here. F is a weaker. Let me just reframe the question. I guess the question should be F is a weaker acid than E, because they mentioned acid there. So it should be F is a weaker acid than E. F is a weaker acid than E. Yeah, that is true, because a weak acid ionizes partially, while a strong acid ionizes strongly. So the one that ionizes strongly, we react faster than one that ionizes partially. So F is a weaker acid than E. So that is correct. Then C says F ionizes less than E in aqueous solution. Yeah, that is true. Based on B, F is a weaker acid. So a weaker acid we ionizes less than a strong acid. So C is correct. Then D says the rate of reaction is the same for E and F. No, that is wrong, because they require the same time. Although they produce the same volume, but the reaction occurs in different time. So their rate of reaction will be different. That was what I was trying to say the other time. So the time at which the two gases were produced, is different. But although they produce the same volume, so the rates will be different. So the only difference here in the graph is the rate of their reaction. So the rate of E is the production of E is faster than the production of F. So say the rate of reaction of E is higher than the rate of reaction of F. I believe you understand that. Do we get that?
Yes, sir.
Yes, sir.
Yes,
Yes, sir.
Question 10 says the presence of a catalyst in a reaction mixture. The presence of a catalyst in a reaction mixture changes the what? Reaction pathway. enthalpy, change of reaction, equilibrium position, yield of the product. Remember I said catalyst, when you add a catalyst to chemical reaction, the activation energy is lowered. So when the activation energy is lowered, it produces a new pathway. I think I showed you a graph from that last class. Let me bring back the graph so you see. Okay. I think I talked about. So look at it now. So the activation energy, the catalyst will lower the activation energy. So the reaction is supposed to go through the pink line, but when you add catalyst, it breaks it down to the yellow line. So that is the new pathway. So a catalyst will create a new pathway by lowering the activation energy. So a catalyst creates a new pathway by lowering the activation energy. So a new pathway will be produced. So the correct answer here will be it changes the reaction pathway. So the reaction pathway is affected as a result of lowering the activation energy. Do you understand it?
Yes, sir.
Sir, please, I have a request.
Now, question number 11 says the change that occurs when a photographic film is exposed to
Are
sunlight.
you hearing me?
What is it?
Okay, sir.
Sorry.
This plate
Sorry,
now
one
that you are
minute,
at this
please.
reaction.
Chemistry sweet. Oh yeah.
What did you say? I asked a question now.
So I don't know if you've explained this reaction before, this exothermic and endothermic. I don't know if you've explained this.
No. That's part of what we are
Okay,
going to do next. I've not. That's why I didn't talk much about this graph. I just show us the graph. I didn't talk more
okay,
about
thank
the graph because we are still going to look at it. So I just introduced the graph
okay,
just to
thank you.
show
Because my
us how
network has been
catalysts
bad.
work. Okay, now let's look at question number 11. The change that occurs in a photographic plate, a photographic film. When a photographic film is exposed to sunlight is what? Remember I told us that conversion of, in a photographic film, silver halide is converted to silver metal. That is a photochemical reaction. What is photochemical reaction? Under photochemical reaction, look at the example. So I said examples include photosynthesis, conversion of silver halide to silver. So silver halide is converted to silver. That is silver ion will be converted, silver ion will be converted to silver metal. So that is the reaction that takes place in a photographic plate. Silver halide will be converted to silver metal. So which of the reactions shows silver halide being converted to silver metal?
Option C.
That is C, right? Yeah.
Sir, please, I'm not seeing the question you're reading, sir.
Question 11. So in a photographic plate or a photographic film, a silver halide is converted to silver metal. So it is a photochemical
that's
reaction. That is so silver halide, that is silver ion, will be converted to silver metal in the photographic film. Do you get it?
Yes.
Now
Yes,
we
sir.
go to question 12 says, which of the following reactions is responsible for an increase in the rate of a chemical reaction on heating? Remember, on heating simply means the temperature is increased. So when you increase the temperature, what effect does it have? A, it increases the enthalpy, increases the collision rate, increases the reactant concentration, decrease the activation energy. So which one is the correct answer? When you increase
Option
temperature,
B.
what does it do?
Option B.
It will increase the collision rate.
B.
Yeah. The particles collide. That is the. Do we get it? Now question 13. I will stop at question 14. So I just want us to go through the questions to be sure you understand what we are doing. Now, question 13 says the reaction between 10 grams of iron filings and 1 mole per dm cube ACl can be made to proceed faster. As you want to make the reaction faster, you want to increase the rate. So how can you make it faster? A, using a 0.5 mole per dm cube acid. Now, if you use 0.5 molar, what concentration are we using before in the reaction?
1.0.
1. So if you are now using 0.5, will it increase the reaction or slow down the reaction?
It will slow down the reaction.
Why? Why will it slow down the reaction?
Because 0.5 is smaller than 1.0.
Yes, the concentration is lower. That's what I was saying. Look at that. B says.
Yes, sir.
B says adding 1.0 mole per dm cube NaOH. Is NaOH in the reaction?
No.
No.
No, sir. C, cooling the reaction vessel. When you cool, what are you doing?
Reducing the temperature. You are decreasing the temperature.
So when the temperature is decreased, what will happen to the reaction? Faster or slower?
It will be slower.
Slower. D, adding some concentrated ACl. That means you are increasing the concentration of ACl. So what will happen to the reaction?
To melt faster.
Make it to be faster.
Make it faster.
It to be faster.
Do we get that? Okay. Question number 14, and that's where I'm stopping. So we'll start with it after that. A rod form of a metal burns less readily in air than the finely divided form because the rod has what? A rod form of a metal will burn less readily.
Option B.
A rod form will burn less than the finely divided form because of what? It's because of the surface area. Finely divided, finely divided iron. Very small particles like it, very small particles of iron.
Yes, sir.
So the small particles, they have larger surface area than the rod. And they react faster because of larger surface area. Because of larger surface area. Larger surface area. Do we get that?
Yes, sir.
So that's where I'm going to stop. Remember we said for a chemical reaction to occur, what are the two conditions that must be fulfilled? The two conditions necessary for chemical reaction to occur. Forgotten. We said that the energy of the reacting particles must be greater than the activation energy. The reacting particle must have sufficient energy and they must be correctly oriented or aligned or properly oriented. Now, we'll now move to heat changes in chemical reactions. Heat changes.
Is this another topic?
Yeah, this is another topic.
It's a subtopic under it.
Sorry,
So
sir.
this is-
Please, what's the answer of number 13?
13. And we said D now, adding some concentrated NaCl. When you add some concentrated NaCl, you increase the concentration of NaCl. And when the concentration is increased, the chemical reaction occurs, the reaction is faster. Do we get that?
So please,
Wait,
what
yeah,
about
yeah.
number 14? Number 12.
F14 says CC, larger surface area. The surface area, the finely divided iron contains smaller pieces than the rod iron. So the finely divided iron has smaller pieces of iron than the large one. So the surface area is higher, so the reaction will be faster. So those are the 7 factors.
Sir, please, can you explain that what does it call it? Question 8 again, please, sir.
The line, look at the graph. At what time does the line become horizontal? And it's after 15 minutes. Horizontal. Can you see the horizontal line?
Yes, sir. Yes, sir.
So the line became horizontal after 15 minutes. So that's where, so the point where the line becomes horizontal is where the reaction stops. Do you get?
Okay, sir. Thank you, sir. Yes.
Excuse me, sir. Number 12, what's the answer?
Please, are you
So
guys,
we have done.
I
We
don't get
said
it. Like, are you guys not in this class when we're doing all
increase
this?
collision rate. It increases the collision rate. Okay, now we go to heat changes in chemical reaction. Now when a chemical reaction occurs, in some cases we have heat to be absorbed. That means there are some reaction that requires heat or energy. And let me say energy in form of heat. Let me put it that way before they occur. While some will give out heat. Now a common example is respiration, for example. Respiration is release of energy when oxygen acts on carbohydrate food. Energy is released. Carbohydrate food, which is majorly glucose. So the addition of glucose with oxygen acting on glucose will release energy. So that is the chemical reaction that releases energy. So the energy may be released in form of heat. There are some other reactions, the opposite reaction now, photosynthesis. Photosynthesis will require energy in form of heat, which comes from sunlight. So it's the sunlight that energizes the chlorophyll. Remember, in photosynthesis, you have the dark stage, you have the light stage. So in the light stage, the chlorophyll is energized as a result of the energy coming from the sun. So the energy in form of heat comes in before the reaction occurs. So that is another reaction. So this reaction, we classify them into two, which we are going to look at. So those ones that release heat and those ones that needs heat before they occur. So in chemical reaction, energy is either absorbed, like for example, why sun releases energy always in form of heat. Respiration releases energy when oxygen acts on it. So this energy, the energy that is released is usually as a result of breaking